we're not going to go all through trig again. Okay, so I'm just going to briefly go through it and just tell you what to watch for. You need to remember trig stuff. Okay, so because all throughout calculus, the trig functions are meant, and the inverse trig functions are all throughout it. So, you know, if you take a business calculus class, they leave the trig out. But for regular calculus series, all the way through, you got trig all through it. So, here, you know, is just if you think about the trig functions as far as the ratios of a right triangle, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, so on and so forth. Right? Occasionally we do have to use that. Okay, so SOHCAHTOA, remember that? Okay, so remember those. That's one way of thinking about trig functions. Okay. Another way is with a circle, which we think of unit circle normally, but here, this would be x, that would be y, which is that point there, and then the radius then would be the square root of x squared plus y squared, just Pythagorean theorem. All right. So definition, trig functions. Let P, a point, x, y, be a point on a circle of radius r associated with the angle theta. Then that would be true. So sine would be y over the radius, or the radius, cosine x over the radius, tangent y over x. And then, these are not in good order here, but cosecant, reciprocal of sine, secant, reciprocal of cosine, cotangent, reciprocal of tangent. Okay? Not inverse, but reciprocal. Okay? And then you have the unit circle. Now, if for a unit circle, what is the radius of a unit circle? The radius, not the circumference, the radius. What's the distance from here to here? 1, right? Unit, all right? 1 unit, unit circle, all right? So the distance is 1, all right? So if you go up here and you put a 1 in the place of all the r's, then you get this. All right. So for if you take an angle here, say 30 degrees, the sine of 30 degrees is going to be whatever that y coordinate is there on that point. The sine of 30 degrees is a half. The cosine of 30 degrees will be whatever the x coordinate is, root 3 over 2. Okay. Now remember all that? Next quiz, going to have about 5 of these on it. All right. And all it's going to do, it'll say, what is the sine of 150 degrees, or 5 pi over 6? What is the cosecant of 2 pi over 3? Okay? You need to remember those, because the thing is, when you get to doing calculus problems later on, you don't want to have to look up what is the sine of 30 degrees every time. You need to be able to figure it out pretty quick. All right? Especially if it's at 0, pi over 2, pi, 3 pi over 2, whatever. You need to be able to just know what that is immediately. If not, you're going to be very, very slow. And you don't want to be slow. You got to move through it. And there's plenty of other things you need to look up when you get to Cal 2 and Cal 3. But this should not be one of them. You know. So now to try to be remembering it. So before next time, which is Wednesday, look back over this unit circle. Be sure you know what these points are, and you can draw them. I will put a video in Moodle that I got that just is a way of, from the YouTube, just of somebody explaining how you can remember the unit circle. So if you don't remember that, it's definitely patterns around the thing. These 45-degree angles are always root 2 over 2, root 2 over 2. You just got to get the signs right in whatever quadrant that you're in. Then the other ones are just either root 3 over 2 or 1/2. So you just got to get them in the right place. You got to get the signs correct. So, as far as what you mean? It'll just say sine of 30 degrees. What is it? So you'd want to be able to draw it and get the angles. So, all right. Okay, so anyway, there's the unit circle. All right, so any questions about that? So if you haven't looked at that in a while, be looking at it. Okay, so, and it's on that trig page that I gave you. And again, radians, y'all remember radians, I guess, right? So all the way around the circle, if it has a radius of 1, the circumference is 2 pi, right? 2 pi r circumference. So all the way around is 2 pi. Halfway around is pi, pi over 2, 3 pi over 2. And then these go up by 6, by pi over 6. So pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So you can keep going around like that, you know, with the radians there. Okay, see any questions? And again, I will put a video on Moodle that will that I've got that will, if you want to look back over that again, you can. So, all right, trig identities. Of course, remember tangent is sine over cosine, which means cotangent is cosine over sine. And then the reciprocal ones, we already talked about that. Cotangent 1 over tangent, cosecant 1 over sine, secant 1 over cosine. So remember the S's and C's go together. Okay, so they don't. Cosecant, sine, secant, and cosecant. Pythagorean identities, need to remember those. Those pop up a lot. Sine squared plus cosine squared equals 1. Usually you can remember that one. If you cannot remember the other ones, if you remember that one, you can get the other ones. All you have to do, sine squared plus cosine squared equals 1. All right. Then if you divide both sides by one of these, all right, say I divide both sides by sine squared. Sine squared divided by sine squared is 1. What is cosine divided by sine? Cosine divided by sine. Tangent, the other one. Cosine divided by sine. Sine over cosine is tangent. So cosine over sine is what? Cotangent, right? Is that what you said? Okay, yeah, cotangent. So cotangent, 1 over sine is what? Cosecant. There's your other one. There's 1, all right? If you divide both sides by cosine squared, sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. 1 over cosine squared is secant squared. There's the other one. All right, so those three, definitely, those will pop up a lot. Okay. Now, the double angle ones and half angles, occasionally, those will come up, but probably not till Cal 2. Okay, so I think through Pythagorean identities is probably all you're going to need as far as this class goes, as far as formulas. And there are other ones besides, you have sum and difference formulas, other things too. So when we need those, we'll look those up at some point. As far as the period of the trig functions go, if you think about their graphs, sine, cosine, secant, and cosecant, the period of the graph is 2 pi. So if you add 2 pi to theta, you just get sine theta back. All right, so that's how long it takes for one complete cycle of that graph. All right, for tangent and cotangent, the period is only pi. That's how far it takes for the whole graph to occur. Okay? Questions? All right, graphs of these things. All right. So here they are. Here's all of them. Okay? So on your paper there, on the graphs to know on the back there, you got the trig functions. And for sine, it's going to be this red one here. All right? You just have the sine wave that goes like that. Cosine is the same wave, except sine goes through the origin. Cosine crosses the y-axis at 1. Okay? For now, that's all I need to remember. If this was a trig class, we'll get into it a lot more. But just remember, that's basically what the graphs look like. Okay? Now, they're reciprocals. Okay? So like the reciprocal of sine is cosecant. So if you think about where this sine graph goes, and everywhere that it crosses the x-axis, you have a vertical asymptote. then the cosecant graph would just be these little circles like this, these little bowl type graphs all the way through. That would be, so you can get that from the sine graph, okay? For cosine, same thing. Cosine is the red one. Secant, you're going to have vertical asymptotes wherever it crosses the x-axis. And again, you have the little bowls that go through there for those as well, okay? Tangent, your vertical asymptotes are at pi over 2, 3 pi over 2, 5 pi over 2, and it goes up just like this. It descends to the left and ascends to the right. Cotangent's opposite. Okay, it ascends to the left, descends to the right. Okay, a big thing about the graphs to remember. Okay, sine and cosine, the domain is all numbers. Okay, but for all the rest of them, for cosecant, secant, cotangent, and tangent, they all have vertical asymptotes. And you need to remember where the vertical asymptotes are at. Because when we take limits in Chapter 2 of something, the limit is going to be at one of those vertical asymptotes probably. Or we'll need to know where that's at. So, just got to remember if it is, if the function starts with C, so cosecant and cotangent, your asymptotes are at 0, pi, 2 pi, 3 pi, 4 pi. Okay? If the function starts with something besides C, t, tangent, secant, the asymptotes are at pi over 2, 3 pi over 2, 5 pi over 2, that kind of thing. Okay? That's something you need to try to remember. Okay? Because that will come up a lot. Okay? Where these asymptotes are at. All right, any questions about that? So stuff to need to remember. All right, so if it's been a while, I know some of you had trig in the spring. Need to try to remember those things. Okay, so all right, so we got that. Now we're looking at inverse trig functions. Okay, so that's all trig function stuff. We also go ahead and do the inverse trig functions. And we don't have many problems, so if we can get through talking about this, I think we can go through the problems pretty quick. So I think we're doing okay with time. All right, so let's talk real quick about these. Okay, let's say we've got f of x equals sine x. All right, that graph looks like this. And it's just a wave that continues forever, right? Does that have an inverse function? Is it 1 to 1? No, if you do a horizontal line test, definitely not going to pass it, right? But we have inverse trig functions. Okay? Well, how do we have inverse trig functions? And they're functions. I know we talked about this in trig. I taught some of you in the spring. Y'all remember? How do we have trig, inverse trig functions if it's not 1 to 1? Just i's, LSC's i's, okay. All right, well, we restrict the domain. Remember that? We should restrict the domain. So what happens is we have to restrict it to where we can have an inverse function, okay? And it's really just defined the way it is. Somebody just defined it a certain way. Okay, I mean, kind of. For sine, the domain is restricted from negative pi over 2 to pi over 2. Okay, so it takes the graph really only from here to here. And then we do the inverse of that part, and that's it. Okay, so sine is negative pi over 2 to pi over 2. Okay, so that means when we switch it and we get, so let's say, so this one, the domain is negative pi over 2 to pi over 2. Okay, that means, and then my range would be negative 1 to 0, right? Okay, so if I do an inverse sine, then that means my range, my domain then becomes the range of this one, negative 1 to 1. Sorry, not 0, negative 1 to 1. The domain becomes negative 1 to 1. The range would be negative pi over 2 to pi over 2. Okay? So, if you take your calculator and you take inverse sine of 2, what's the calculator going to do? It's going to fuss at you. It's going to say domain error, probably. Okay? What does it say? Domain error. There you go. Yeah. Because 2 is out of the domain. All right? It's only negative 1 to 1. That's how inverse sine is defined. All right? Because we're limiting this one to just that part right there. Okay? Now, so that means I can only put in numbers between negative 1 and 1. So what if I put in a number? Okay, like say I put in, let's go back to a unit circle. All right, there's unit circle. All right, so say that I put in, say I want to take the inverse sine of 1/2. Okay? So on the unit circle, I would say, well, okay, well, what y values are, where are the y values a half? All right, well, I've got one right here. Where else do I have one? Right there. So is the inverse sine of 1/2 pi over 6, or is it 5 pi over 6? Not technically. If you're solving an equation, yes, for equation. But as far as actual inverse sine, if you put it in your calculator, if you do inverse sine of 1/2, it's going to give you one value. Which of the two will it give you? The pi over 6, and why? Because it matches the range. All right. The range goes back to where this thing is restricted. All right. It's restricted from pi over 2 to pi over 2. What quadrants is this in? 1 and 4. All right. So inverse sine, it is defined to be the angle in quadrants 1 or quadrants 4. And notice every y value is different in quadrants 1 and 4. They don't repeat. So they repeat in 1 and 2 for sine, for y. Okay? So everybody follow how that works? So calculators are defined to do that. Okay? That's where it's defined. And so inverse sine, cosine, tangent definitely are restricted a certain way. Now, inverse cosine is going to be restricted from 0 to pi. Okay? So 0 to pi. We'll look at that in just a minute. But notice cosine is the x value. Well, notice from 0 to pi, what's true about all the x values? They are all different. Okay? In quadrants 4 and 1, the x values are all the same. So that's why cosine can't be restricted to negative pi over 2 to pi over 2, like sine, because it wouldn't work. But from 0 to pi, that does work. Okay? Does that make sense? Okay, so back to these inverse trig functions. All right, so here is sine. Okay? So I drew the red one there, the sine. This is what you get if you do the inverse sine. You don't have to memorize the graph to these, okay? But sine is negative pi over 2 to pi over 2. So inverse sine is defined in quadrants 1 and 4, okay? Inverse cosine is defined in quadrants 1 and 2, okay? Tangent is quadrants, is from negative pi over 2 to pi over 2. So that's quadrants 1 and 4. Those are the main three. You're not going to see problems much with inverse, cotangent, cosecant, and secant. You might, and we do have formulas for derivatives and integrals of those, but you don't do a lot with those, really. But remember, sine and tangent is quadrants 1 and 4. Inverse cosine is quadrants 1 and 2. It's where they're defined. Now, they do go ahead here and define these others. I think sometimes there is some disagreement on these because you can really restrict the domain how you want to. And it may be the way you plug them in. I think Desmos, I showed y'all Desmos before on here. Okay, if you graph on Desmos, I think it does different than the calculator. It depends on how you plug it in the calculator too. But this is what they've defined. They've defined inverse cotangent to be 0 to pi, inverse secant 0 to pi, and then inverse cosecant negative pi over 2 to pi over 2. Okay, so cotangent does not match tangent, but secant matches cosine and cosecant matches sine. So there you go. All right. Any questions? There's the graphs of those. You can pull those up and look at them. All right. I'm going to write these on the board. Let's go back up here to this unit circle, and I'll work these real quick, and we'll be done. 10 minutes. All right, we can do it in 10 minutes. So these are the kind of problems that will be on the quiz. So next week. So next time on Wednesday. So you'll have 5 of those graphs like we did today. Okay. So 5 of the graphs, and then 5 of those problems like this. Okay. So cosine of 2/3. Okay. So what I need to remember there, cosine corresponds with the y coordinate. So I would go to my unit circle to 2 pi over 3, which is here. 2 pi over 3, what's the x coordinate? Negative 1/2. So the cosine of 2 pi over 3 is negative 1/2. All right, that's all I got to do. All right, questions about that? Let's see. Let's do the tangent one. All right, so tangent, remember, is the y over x. Okay? Negative 3 pi over 4. So this would be in the clockwise direction. Okay, so if I start here, this would be 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4. Okay, follow that? Now here's my point. Okay, so tangent is y over x. Got to remember that. Negative root 2 over 2 divided by negative root 2 over 2. How much is that? 1. Okay, so that's equal to 1. Any questions about that? Okay. Let's see. Let's do... I'll go and do a sign. All right, 16 pi over 3. Okay, where in the world is 16 pi over 3? Well, I would probably... You could do one of two things. You could count. Okay? So, if you counted it, you could go... Think of the circle in thirds. So that would be 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. Keep going. Well, how many thirds would you have all the way around twice? 12 and another... that's enough, isn't it? 12. All right. So you'd have... Well, I got to go to 16. All right. 12, 13, 14, 15, 16. 16 pi over 3. Does that make sense? And what's that asking for? Sine. Y value. Negative root 3 over 2. Is that right? Okay. Any questions about that? Okay. All right, let's see. Let's do secant. All right, secant is the reciprocal of what? Cosine. Cosine is x. So that will be 1 over x. Right? Okay? 7 pi over 6 is here. X coordinate, negative root 3 over 2. Right? So negative root 3 over 2 flipped would be negative 2 over root 3. Okay. I'd be okay with that, but we still want to rationalize our denominator probably. All right, especially in my math lab. So multiply the top and bottom by root 3, and you get negative 2 root 3 over 3. Okay, questions about that? Cotangent. Cotangent would be what over what? X over y, reciprocal of tangent. So x over y. All right, negative 13 pi over 3. All right, so we got to go backwards. Is that the same as the other one? No. Well, if I go all the way around, how many thirds do I have all the way around? 6. All right, 6 pi over 3. So another time around would be 12 pi over 3. I'm looking for 13. So 1 more pi over 3, which would be here. All right, I get that point. Okay, what am I doing? Cotangent. So I need to do 1/2 over negative root 3 over 2. Okay, so what does 1/2 over negative root 3 over 2 reduce to be? 1 over root 3, and then that would be what? What did you say it? What else did you say? That. Okay. All right. And really, cotangent and tangent on the unit circle is either going to give you root, if you're on one of those root 3 over 2 1/2 points, it's either going to be root 3 if it's root 3 over 2 divided by 1/2, or root 3 over 3 if it's 1/2 divided by root 3 over 2. Okay. One more. And then we'll just pick up with these other ones. We can do these other ones next week at the very beginning. So go ahead and, well, let's do this one first. All right, cosecant negative pi. Okay, so negative pi would be over to here. Start here and go this way. Okay, my point there is negative 1, 0. Cosecant, that is a reciprocal of what? Sine. So it's 1 over y. The y coordinate there is 0. What is 1 over 0? Is it 0? 1 over 0 is undefined. Right? You can have 0 over 1, but not 1 over 0. So cosecant of negative pi is undefined. Okay? Any secant, cosecant, tangent, or cotangent will have places where it is undefined. Okay? Graphically, what are you looking at cosecant negative pi? What would you be looking at as far as the graph goes at that place? That is where your vertical asymptotes will be, right, wherever it's undefined. So, okay. So real quick, so go ahead and work on homework 1.3 and do what you can in 1.4. We'll finish this up next time. We'll just have a few equations, do a few little things, and then we'll get started with chapter 2. So quiz next time will be about 5 of those unit circle problems, where you just, like I told you, the graphs, go ahead and know through 18. 18 is through the trig functions, okay? So go ahead. You should already know them, really. But be looking through those, and some of those will be on there. Don't worry about 4, that greatest integer function. We'll wait, see. Or number, yes, do those. Yeah, don't worry about 10. You can mark off 4 and 10 for now, if you want to. Mm-hmm. Need to be able to tell what is the sine of 7 pi over 6, or what is the tangent, or the cosecant. So you need to remember cosecant is 1 over y, secant's 1 over x, that too. But just unit circle, no negative angles, no angles bigger than 2 pi.
Well, one of the things that we're not going to be able to look at it and count on like you just did.
Right, you got to know it. So what you want to do is just kind of draw what you need. You don't want to draw the whole thing, but just know if I'm looking at, pi over 6, then I know what I can find that pretty quick what that point is. All right. All right, let's finish up this trig stuff here, and then we will get on into chapter 2 today. So, last thing we did was secant 7 pi over 6. Is that right, I guess? Okay, all right. So next is just a couple of really simple equations. And what we want to do, let me go ahead and just go back to the unit circle, and I'll work these over here, and we'll just refer back to the unit circle. Go a little short smaller here. Okay. All right, so the first equation we've got is tangent x equals 1. And then the second one we'll go ahead and write up here is cosine squared theta equals 1/2. And then it says theta is between 0 and 2 pi. Okay? So notice, how are the answers going to look different on these two equations? Well, for the second one over there, we're only looking for the answer for the angles between 0 and 2 pi. So that one is going to have a finite number of answers. Okay, this is have a certain number. This one though, tangent x equals 1, there's an infinite number of x's that will be true for this. All right. So here you've got to express your answer to where you show all the solutions. Here you're only going 0 to 2 pi. All right. So what you can do here, tangent x equals 1. All right. You got to remember tangent is y over x on the unit circle, right? So to get 1, y and x needs to be the same. So what angle on the unit circle are y and x the same?
45.
45 degrees, pi over 4, all right? Right here. All right, root 2 over 2, root 2 over 2. So this pi over 4 would be a solution, okay? Also, you've got, not that one, sorry, 5 pi over 4, you got negative root 2 over 2, negative root 2 over 2, okay? And then if you keep going, another distance of pi, you get to this one, and that'll be another one. Another distance of pi would be this one again, right? So every time you just go up a distance of pi, you get another solution. So write the answer. I would say x equals pi over 4, and then like I said, the period of tangent is pi. That's how long it takes for a whole cycle. So I would just say k times pi, where k is an integer. Okay, questions about that? Now again, this one, we're only looking for the answers between 0 and 2 pi. All right, so here I would square root both sides first. So I get cosine theta equals plus or minus root 1 over 2. Okay, so yeah, that's 1 over root 2. If you rationalize your denominator, then that's going to be root 2 over 2. Okay, so I'm looking for, going from 0 to 2 pi, where is the x coordinate on the unit circle? Either positive root 2 over 2 or negative root 2 over 2. Okay, so if you look at your x's, really at every 45 degree angle, right here, the x is root 2 over 2. Here, it's negative root 2 over 2. Here, it's negative root 2 over 2. And here, it's positive root 2 over 2. So all 4 of those angles would be solutions to this one. So I'm just going to list them. Theta equals pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay? All right, any questions about that? All right, just a couple more here of these. All right, so again, two types of equations. The first one, theta, there's an infinite number of theta that would be true for the first one. This one, we're only looking for the x's that work between 0 and 2 pi. Okay? So for this one first, I would say, all right, sine squared theta equals 1. Square root both sides. Square root 1 is 1. So I'm looking for when sine is plus or minus 1. Okay? So let's go to unit circle. Sine corresponds with the y-coordinate. So the y-coordinate is 1 or negative 1 right here at pi over 2 or at 3 pi over 2. Okay? So notice on this one, if I can go from pi over 2 to 3 pi over 2. That's the distance of pi. Then I can go back around again and I get to another one. Another distance of pi. Another distance of pi. All right? So for this one, I could just write it as just pi over 2 plus k times pi. All right? You could do, I guess, pi over 2 plus k, 2k pi, and 3 pi over 2 plus 2k pi. But with that particular one, since your solutions are always a pi apart, then you can just write it like that. So I would just write the answer on this one. Theta equals pi over 2 plus k pi, where k is an integer. Okay? All right, questions about that one? Normally, if you had, say this equation was just sine x equals root 2 over 2. How many solutions would you have in one revolution of the unit circle if this was just sine x equals root 2 over 2? You'd have 2 solutions. Okay? What does 3x, what is the 3, how will that change that, you think? Well, let's see what happens. All right, so root 2 over 2, sine, so that's going to be your y-coordinate. Root 2 over 2 is at pi over 4 and 3 pi over 4. Okay, sorry. So 3x equals pi over 4. 3x equals 3 pi over 4. All right, well, if I divide by 3, I get x equals pi over 12 there. Here I get x equals pi over 4. Okay? Or is that the only 2 solutions? No. All right, because I mean that's just a small part of them. All right, so if I went on around again, so I've got pi over 4, 3 pi over 4, then I would have 7 pi over 4, 5 pi over 4, sorry, 7 pi over 4, 8 pi over 4, then I would have 9 pi over 4 again. If I get to 9 pi over 4 and divide by 3, what does that one give me? That gives me 3 pi over 4. All right. So you continue getting solutions, okay? So how could you do that? Well, you could either do what I was doing and write all those out, and then I would have 10, 11 pi over 4. All right, so that would give me x equals 9 pi over 12 is 3 pi over 4. Divide by 3 here, that's going to be 11 pi over 12. Okay, is that all of them, you think? We really should have 3 times as many as normal. Normally you have 2, so how many should we have if we multiply by 3? Should have 6 within the same interval. Okay, so I got 4, and this only goes almost halfway around the circle, right? So if you just do a few more here, all right, so I'm at 11. All right, so that'd be 12, 13, 14, 15, 16, 17. Is that right? Yep, 17 pi over 4. And then that'd be 17, 18, 19 pi over 4. So x is also equal to, if I divide by 3, 17 pi over 12. X is equal to 19 pi over 12. So that would be all the solutions between 0 and 2 pi for that equation. Okay. Without using a calculator, evaluate the expressions or state that the quantity is undefined. Okay. All right, so I'm going to write a few of these up here, and this is just looking at the unit circle and figuring out what these are. Okay, so let's look at those. All right, so all these are just inverse trig. All right, so what is the inverse sine of 1? The inverse sine of 3 pi over 2. All right, so it's asking for what the sine of what angle will give me 1. The sine of what angle gives me root 3 over 2. All right, everybody follow that? So in the unit circle, I need to see, for this first one, when y is 1, what angle is that? Right, because sine goes with a y. Okay. Now the thing to remember we were talking about last time with these trig functions was how is the domain restricted for sine, cosine, tangent, all of those in order to find these. Okay, well, for sine, where was the domain restricted for sine? What quadrants? 1 and 4. All right, tangents 1 and 4, cosines 1 and 2. We'll worry about the other ones when we get to them. All right, so, but you need to remember that. All right, so for sine, I'm only going to look in quadrants 1 and 4 to see where is y 1. Okay, and y is 1 right there. Okay, so that angle is pi over 2. So the sine of 1 is pi over 2. Inverse sine of 1 is pi over 2. Okay, inverse sine of root 3 over 2. So where is the y root 3 over 2 in quadrants 1 and 2? Be right here at pi over 3. Okay, it is not 2 pi over 3. That's not where the inverse sine function is defined. It is defined to be pi over 3. Okay? Any questions about that? Go ahead and do inverse sine of negative 1/2. Okay, so in quadrants 1 and 2, where is the y value negative 1/2? Right here. Do we say 11 pi over 6? Do we say, nope, what do we say? Negative pi over 6, all right, because the interval is from negative pi over 2 to positive pi over 2, right? So we need to call it negative 11 pi over 6. I'm sorry, negative pi over 6. All right, questions about that? Okay, we have two kind of, but one here, inverse cosine of negative 1/2. So remember, inverse cosine is defined in what quadrants? 1 and 2. So the x is negative 1/2 in quadrant 2 right there. So 2 pi over 3. Okay, it is not 7 pi over 6. Okay, because that's not where the domain is restricted. All right, so 2 pi over 3. All right, this one, the cosine of the inverse cosine of negative 1. Now I think we got 2 of these. You might say, well, that's just negative 1. It could be, but you really need to look at not necessarily. Okay, so inverse cosine of negative 1. So in the first 2 quadrants, x would be negative 1 there, which would be pi. All right, so 0 to pi, pi would be it. And then what is the cosine of pi? It is negative 1. All right, so it does work out on that one, but again, if we were in a trig class, we could do a lot more with that, but we're just trying to review a little bit. All right, let's look at the 2 tangent ones. All right, so for tangent, Inverse tangent there, it's defined in quadrants 1 and 4 again, negative pi over 2 to pi over 2. So tangent is of square root 3. Now remember, with tangent and cotangent, you're either dividing x by y or y by x. So if you, of course, the root 2 over 2 angle is easy. That's 1. Root 2 over 2 over root 2 over 2 is 1. The other two, if you have root 3 over 2 divided by half, that reduces to be root 3. If you have 1/2 divided by root 3 over 2, that reduces to be root 3 over 3. Okay? So if I want to find root 3, then that means the top number needs to be root 3 over 2, and the bottom needs to be 1/2. And for tangent y over x, y needs to be root 3 over 2, x needs to be 1/2. Okay, everybody follow that? So where is the x, 1/2, and the y, root 3 over 2? Right here at pi over 3. Okay, questions about that? Okay, so root 3, pi over 3. Okay, let's see. Is that all the tangent ones? Yeah, all right. Okay, this one, the tangent of pi over 4. What is the tangent of pi over 4? One, right? 1. And then what is the inverse tangent of 1? Pi over 4. Okay. Now, if this had said, what is the inverse tangent of the tangent of 3 pi over 4? Okay, say they said that. What is the tangent of 3 pi over 4? Is that negative 1? All right. So inverse tangent of negative 1. What is the inverse tangent of negative 1? How much? Negative pi over 4. All right. So you can't always say, well, these are just inverses, so this would have to be 3 pi over 4. It's not. It's negative pi over 4. Because when you take the inverse tangent, it's in quadrants 1 and 2. Okay? Any questions about that? All right. Now, these other ones, I don't remember those. Let's see. All right. So where was secant? Where was the domain restricted for inverse secant? Quadrants 1 and 2. So it matches with cosine. Okay? So this is the same thing as the inverse cosine of 1 over 2, right? So where is the x coordinate 1 over 2? We're at pi over 3, so that's going to be pi over 3. Okay. Cosecant, that is the inverse of sine. So that would just be that would still be negative 1, inverse sine of negative 1. And let me be sure I've got the quadrants right on that. So cosecant is the same as sine, quadrants 1 and 2. So what would inverse sine be there? Is it negative pi over 2 at the bottom? That's where the y is negative 1. Okay. Questions about that? All right. And then that one, that is the same thing as that if you rationalize your denominator. Okay. So that means the top number is 1/2, bottom number is root 3 over 2. X needs to be 1/2, y needs to be root 3 over 2. Cotangent, let's see if that matches tangent. They have inverse cotangent. It actually doesn't. They have inverse cotangent quadrants 1 and 2. So where in quadrants 1 and 2 would the x be 1/2 and the y be root 3 over 2? Quadrants 1 and 2. I'm sorry, it's negative. Sorry, one needs to be negative. I thought that wasn't working. One of them needs to be negative. Okay, so it has to be in quadrant 2, right? In quadrant 2, your x is negative 1/2, y is root 3 over 2, so 2 pi over 3. Okay. All right, any questions about that?
Where are you getting what quadrants you're supposed to be in?
Okay. Okay, on the so on the domains are restricted in order to have the inverse trig functions. All right. So if you want to print off this page off of Moodle, I have it on. It's on here, but sine is always in quadrants 1 and 2. Negative pi over 2 to pi over 2. So really, the main three that you're going to use: sine, cosine, and tangent. Inverse sine, inverse tangent is quadrants 1 and 4. Inverse cosine is quadrants 1 and 2. And then these other ones, I haven't looked those up, but they're on the paper here. Okay. Normally you won't be doing inverse secant, inverse cosecant, inverse tangent much. But you definitely need to know that about inverse sine, cosine, tangent, because as we go through, you'll have to take the inverse sine of something from time to time. And you need to know that it's defined in those quadrants. That's not always emphasized in trig classes. It should be, but it's not always. So, all right, so any questions? All right, use a right triangle to simplify the given expressions. All right, so let's just pick a couple of those. Let's just do that first one there. All right, so look at what we're looking at. Okay, so we want to figure out what expression that is equal to given what we're given. Okay, so when it says the inverse sine of x over 3, what does this represent right here? Okay, when you find an inverse of a number, inverse sine of something, what are you finding? The what? Okay. Okay. If I want to say when I found inverse sine of 1/2, what was I actually finding there? An angle. An angle. All right. So it's an angle. So anytime so the sine of what angle gives me pi over 2. All right. So here, this represents an angle. Okay. So what you can do is you can just draw a right triangle. And you can say, okay, this is that angle right there. Okay? If this is that angle, then I know the inverse sine of this angle is going to be x over 3. Well, I know from way on back in geometry in high school maybe that sine is the opposite over hypotenuse. So I can let this side be x, this side be 3, and then with Pythagorean theorem, I can see that this side here is going to be the square root of 9 minus x squared. Okay. Then I know, since this is the angle right there, then that means the cosine of this angle, cosine is adjacent over hypotenuse, will be this over this. So that is equal to root 9 minus x squared over 3. Okay. Questions about that? Okay. Let's do one more. Let's do that last one there. Let's do cotangent of the inverse of 2x. Okay. All right, same idea. This is an angle, right? So I could just draw a right triangle. This is going to represent the angle. So the tangent of this angle is going to be the opposite over the adjacent. So 2x over 1. So that's 2x, that's 1. Pythagorean theorem, this side would be the square root of this squared plus that squared. So I get that triangle. Cotangent is the inverse of tangent. So if tangent is opposite over adjacent, cotangent is adjacent over opposite. So, and I really don't even need to know this, do I? So I could just So the adjacent over opposite would be 1 over 2x. And there you go. Okay. All right, any questions about that? It's a little review of trig. All right, but now the things that I've emphasized, if you can keep those straight, you'll be a lot happier as we go through. Okay, so, just work on it. All you gotta do is work on it a bit, and you can, you'll be fine. So, all right, let's start calculus. All right, so this will be 2.1.